Today we're going to learn how to solve systems of equations using graphing. So you should be on page 26 in your notes packet. We know that the solution to a system of equations is always an ordered pair. This is because a system of equations is technically two linear equations and the solution is where they intersect. So that's why we write our answer as an ordered pair. To solve a system of equations by graphing, there are several steps you must take. Graph each linear equation by graphing the y-intercept, then using the slope to find at least one more point, and sometimes you have to find more than that. Find the intersection of the two lines. That point will be your solution. If the lines intersect in one place, we would say that there is one solution. If the lines are parallel and they do not intersect anywhere, then there are no solutions. And if the equation makes the same line, there are infinitely many solutions because there are an infinite number of points where they intersect. So our first equation in example 1 says y equals negative x plus 2. Well, remember that in order to graph a linear equation, it has to be in that form y equals mx plus b, where m represents our slope and b represents our y-intercept. So let's start with this first equation. In this equation, we see that y is by itself, so this equation is already in that form. So I just need to know my slope, which is that coefficient of x. Well, I see that there's just a negative sign in front of x, but remember that means that there's an invisible -1. So the slope for this equation is -1. The y-intercept for this equation is +2 because of this +2. Now, when I find slope, remember that with my slope, when I'm graphing, I always need to graph a rise over a run. So going up or down first and then left or right second, which means that when I graph a slope, it's really going to be beneficial for me for this to be in fraction form. So because this number is an integer, we can just put a 1 under it to make it a fraction. By doing this, I can see that I have a rise of -1 and a run of +1. So let's graph this. Our y-intercept is +2. So from the origin, I would go up to +2 and put a point. That's my first point. Then my slope is -1 over 1. Well, that's a rise of -1. When I have a rise of -1, that means that I'm going down 1. My run is +1. So because that is positive, I will go right 1. Now, I probably want to do this a few times. So down 1 again and right 1, down 1, right 1, until I get a good number of points that maybe I can find something that will intersect. Remember that you can also write the slope because sometimes you'll notice that you'll do this and you never find an intersection. Well, you can also write the slope in the exact opposite way. So I can change both the rise and the runs to their opposite. So -1's opposite would be +1, and +1's opposite would be -1. Because both of these, if I divided them, would still equal my original slope of -1. If I did this and I went back to my y-intercept of 2, a rise of +1 would mean I would go up 1. Then a run of -1 would mean that I would go left 1. So from here, I could also go up 1 and left 1 to find more points. Now, once I think I have a good number of points, I can connect them. Sometimes you'll notice that you do this and you still have to go back and go further. But for right now, that looks like it might be good enough. So let's look at our next equation. Well, that equation is not in the form y equals mx plus b. We have -4x plus 2y equals -2. Y has to be by itself. So y is right here. Well, the first thing we need to get rid of is this -4x. So we need to do the inverse of -4x because remember, we always look in front of it, not behind it. Well, since that's a -4x, the inverse is +4x. So I will add 4x on both sides of this equation. Now, -4x plus 4x is 0, so those cancel. and I'm left with positive 2y, which I'll bring down. Now this says negative 2 plus 4x. I cannot put those together because they are not like terms. Now, I can either write negative 2 plus 4x, or I prefer to have my x values first. So I know that this is a positive 4x because it was being added, so I can just write 4x. And because this was a negative 2, I can write minus 2. If you had written negative 2 plus 4x, it does not change anything. It's still the same thing. So now you can see we're one step closer to having y by itself. However, y is still being multiplied by this 2. So we have to do the inverse, which is dividing by 2 on both sides of the equation. These 2's will cancel to leave me with y equals. And now remember that on this side of the equation, since I'm dividing, I have to divide every term by this 2. Well, 4x divided by 2 is 2x. And remember, this is a negative 2. So negative 2 divided by positive 2 is negative 1. To show that, I would write minus 1. Now that I have it in this form, I can see that I have a slope, and that's my coefficient of x, so it's 2. And I have a y-intercept, which is this not 1, but minus 1, so my y-intercept is negative 1. Remember that my slope would be better written as a fraction. So if I have 2, that's the same as 2 over 1. It's also the same as taking both 2 and 1 and changing them to their opposites. So the opposite of 2 is negative 2, and the opposite of 1 is negative 1. 2 divided by 1 still gives me 2, and negative 2 divided by negative 1 also gives me this positive 2. So writing this in either way is not changing the value. So now I'm going to graph this equation. So I'm going to start at my y-intercept of negative 1. So I will go down to negative 1 on my y-axis. Then my slope is 2 over 1. Well, that's a positive 2 over a positive 1. So that is a rise of up 2 because it's a positive 2, and a run because it's positive 1 of right 1. So you can see that I intersect my first line right here. Now I probably want to have at least one more point just to make it so I can see that line clearer. So I can from here go up 2 and right 1 again, and I have enough points to make a good line that I will connect. Now, my solution. So we've done all this and we've done a lot of graphing, but we haven't found the solution. The solution is the point at which they intersect. So your solution is the ordered pair. Now remember, your ordered pair is always written as your x value first and your y value second. You can see that this point is your solution. Well, from this point on my y-axis, there is a y value of 1. X-axis, I'm sorry. On my x-axis, there is an x value of 1. And on my y-axis, there is a y value of 1. So the solution here is that x and y are 1. This would be my answer. Example 2 says y equals 2x plus 2 and y equals 2x minus 2. Well, let's start with our first equation. Both of these already have y by themselves, so I don't have to do any manipulating of my equation. I can just find their slope and their y-intercept. Well, for this one, the slope is 2 because that is my coefficient on x. My y-intercept is this positive 2 because it's being added by 2. Remember, my slope should be in the rise over run form, so since it was a whole number, I'll just put it over 1. I also could have written that as the opposite of 2 and the opposite of 1, so negative 2 over negative 1. Now, we'll graph this by finding our y-intercept first, which is positive 2. So we will go up to positive 2. Then we'll graph our slope. Well, that's positive 2 over positive 1. So because the rise is positive 2, we would go up 2, and the run is positive 1, we would go right 1. Again, up 2, right 1, and I kind of run out of space. So I could go back to my original point, my y-intercept, and I can also use this slope of negative 2 over negative 1. Since that has a rise of -2, I can go down 2, and a run of -1, I can go left 1. So again, down 2, left 1. So I have a pretty good line here, a pretty good number of points. I probably can connect those and be able to find my next line. Well, my next line is y equals 2x minus 2. So in this one, I have a slope that is 2 because that's my coefficient on x. So you see that we have the same slope here. So we have 2 over 1 or -2 over -1. But the y-intercept is different, so we know we have a different line because the y-intercept is not +2 like it was in the first one, but actually -2, which means it's -2. So I'm going to start with my y-intercept, and I'm going to go down to -2 and put my point. Well, then I use these slopes, so 2 over 1, or I can use -2 over -1. If I do +2 over +1, that's up 2, right 1. And then up 2, right 1. Up 2, right 1. Up 2, right 1. So I have not gotten to a point where they intersect yet. So let's try the other way. Down 2 and left 1. Well, down 2, left 1 puts me here. Down 2, left 1 puts me here. What you'll notice is that these are never going to intersect. If you look at these lines, they run parallel to each other. So because these are parallel lines, they will not intersect. So what this tells you, and you can actually do this without even graphing, you can tell that these are parallel lines because the slopes are the same, but the y-intercepts are different. What that means is that they will start in different places. So they start in different places on the graph because this one starts at +2 and this one starts at -2. But they change, so they go up by a slope of 2, so their steepness is 2 everywhere, which means that they are changing by the same rate every time. Because they start in different places, but they change at the same rate, they will never intersect. So that makes them parallel lines, and because they will never intersect, there is no solution to this system of equations because parallel lines don't have a solution. Example 3 says y equals x plus 3 and -x plus y equals 3. Well, let's start with y equals x plus 3. For this one, we have a slope of, it looks like nothing, but remember, there is an invisible 1 in front of x, so our slope is 1. Remember that slope could be rise or needs to be rise over run. So if it's 1, we can write that as 1 over 1. And we can also take this and change both of these to their opposites. So the opposite of 1 is -1, and the opposite of this one is also -1. So it can be written in either of these ways. My y-intercept is this +3, so my y-intercept is +3. So let's graph that. If my y-intercept is +3, I'm going to go up to +3 and put a point. Then my slope is 1 over 1. Well, if I use +1 over +1, that's up 1 and right 1. Up 1, right 1, up 1, and right 1. Well, then I also could have used -1 over -1, which means that if I started at my y-intercept of 3, I could have also gone down 1, left 1, down 1, left 1, down 1, left 1. So I've got a pretty good line here. So let's connect these points. And let's see what happens with my second line. My second line is not in the y equals mx plus b format. It is -x plus y equals 3. We know we need to get y by itself, so we need to get rid of this -x on this side. Well, I'm going to do that by using the inverse operation. So instead of -x, I'm going to add x on both sides. Well, these will cancel, and I'm left with positive y, which is just y, and 3 plus x. Well, again, I like to write my x values first. So since that's plus x, I know that's a positive x. And since that's a positive 3, I can write plus 3. Well, if you notice, this is the exact same equation that we started with. So this has the same slope of 1 and the same y-intercept of positive 3, which means that when I graph it, I'm going to start at positive 3. I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, and you'll notice that it's the exact same line. Since it's the exact same line, that means that there are infinite solutions. So for this one, you know that we have the same slope and same y-intercept. That means that the line is the same. So because of that, our solution is that there are infinite solutions because this line goes on forever, and there are infinite number of points where they will intersect. Example 4 says 5x plus 3y equals 6. So let's start with that equation. Well, if we have 5x plus 3y equals 6, we know we need to get y by itself. We need to start by eliminating this 5x. Since that's a positive 5x, I'll do negative or minus 5x on both sides. Well, these will cancel, and I'm left with positive 3y. On this side, I have 6 minus 5x. They're not like terms, so I don't combine them. But I also could write it so that x came first. So since that's a minus 5x, I could write negative 5x. And since that's a positive 6, I could write plus 6. Now we're closer to having y by itself, but it's still not quite by itself. We still need to divide by 3 on both sides of the equation to get y by itself. Well, these will cancel, and now we have y equals. Now, on this side of the equation, you know that you have to divide every term by that 3. It is very easy to look at this and say, well, negative 5 can't be divided by 3, so what do? You leave it exactly as it's written. Remember, you know that the slope needs to be in the form rise over run. So if this is negative 5 divided by 3 and it's not a whole number or an integer, then leave it as negative 5 divided by 3 or negative 5 over 3. And then just put the x with it. This next one is positive 6. We know it's positive because that plus sign. So 6 divided by 3, well, that is 2. And since it's positive, we'll put plus 2. Well, so from this, we can see that we have a slope of negative 5 over 3. And we have a y-intercept of plus 2, which means it's positive 2. Now, remember your slopes, sometimes you'll go one direction and you'll find out that in order to intersect your other line, you actually need it to go another direction. So another way of writing this is to put both of these as their opposites. Well, the opposite of negative 5 is positive 5. And the opposite of positive 3 is negative 3, because both of these would give us a negative 5/3. So let's graph this. If our y-intercept is positive 2, we would go up to positive 2 on our y-axis. If our slope is negative 5 over 3, the negative 5 is our rise, so that means we go down 5. So 1, 2, 3, 4, 5. And then our run is positive 3, so we would go right 1, 2, 3. So this would be our next point. Well, if we had done the other one, which was positive 5 over negative 3, if we started from here, we could go up 5, 1, 2, 3, 4, 5, and then left 3, 1, 2, 3. So you can see that we can connect these points and make a line. Although my line is not a good line. All right, so from here, we're going to look at our next equation, which is 3x minus 2y equals 8. For 3x minus 2y equals 8, we know we need to get rid of this 3x first, so we are going to subtract 3x because that's a positive 3x, so the inverse is minus 3x on both sides of the equation. These will cancel, and we're left with negative 2y equals, Well, 8 minus 3x cannot be combined. They're not like terms, so I'm going to write it as negative 3x plus 8. Then to get y by itself, we're going to divide by negative 2 on both sides. These will cancel, and we have y equals. Well, a negative 3 divided by a negative 2 is going to actually give us a positive, but it's a decimal. So we really just want to leave it as a fraction. But you do know that a negative divided by a negative is a positive. So this is positive 3 over 2x. Positive 8 divided by negative 2 is negative 4. So we also have minus 4. So when we graph this, our slope is positive 3/2. Or we could write it as both of these opposites. So the opposite of 3 is negative 3, and the opposite of 2 is negative 2. And our y-intercept is this negative 4. So if I graph that, I would go down to negative 4 first. And if I use 3 over 2, that's a rise of up 3 and right 2. So you can see that it probably intersects somewhere over here, although it's hard to tell because we can't see exactly where that might be. So for this one, I wouldn't say that it's exactly 2, negative 1, because it's probably not there. Also, I did not draw my line very well. But with this one, you can see that they do intersect. We know that this has a solution. It's just hard to tell on your graph exactly where that is. So for example 4, and you will not see any examples like this on a test or work that you have to do, but every now and then you'll run across something random where you can't find the exact value. So in this case, it might be better to use either substitution or elimination to solve this equation so that you can figure out what x and y equal. Example 5 says y equals 2x minus 3 and y equals negative 3x plus 2. Well, for this, you can see that both of these are already in y equals mx plus b form. So for our first equation, our slope is this coefficient of x, which is 2. Now remember, we want that to be in a fraction, so we want to put that over 1. Another way to write that would have been both of these as their opposite. The opposite of 2 is negative 2. The opposite of 1 is negative 1. Then our y-intercept is this minus 3, which is negative 3. So if we graph that, we'll go down to our y-intercept of negative 3. If our slope is 2 over 1, that's a rise of up 2 and right 1. So up 2, right 1. Or I could have done negative 2 over negative 1, which would have been down 2, left 1. So either of those slopes would have worked. Now let's look at our next equation, which is y equals negative 3x plus 2. In this equation, our slope is negative 3. So remember, that can be written as negative 3 over 1. Or I could change that. Negative 3's opposite is 3, and 1's opposite is negative 1. Again, if I divided this, I'd still get a negative 3 as my slope. My y-intercept is this plus 2, so my y-intercept is positive 2. So let's graph our y-intercept first by going up to positive 2 on my y-axis. My slope is negative 3, so I'm going to go down 3 and then right 1, which puts me right here. And you can see that that's the same point that was on my other line. So I found the point where they intersect, and that point is right here. So I need to write the ordered pair for that. Well, the ordered pair for this is that my x value here is 1, and my y value here is negative 1. So my solution is positive 1, negative 1. Now let's look at our last example. This first one is x minus 4y equals negative 4. It's not in y equals mx plus b form, so we need to change that. Well, the first thing we need to do is get rid of this x, so that's a positive x, so we'll negative or minus x on both sides. Well, these will cancel, and be careful because I'm not left with 4y, I'm left with negative 4y. Then I have negative 4 minus x, or I can write that as negative x minus 4. Now, y is still not by itself because y needs to be divided by -4. So we will divide by -4 on both sides. Well, that leaves us with y equals, well, you want to be careful here. Remember, I know I see a negative in front of the x, but that's actually a -1x. So -1x minus 4. Well, I can do -1 over -4. Well, a negative divided by a negative is a positive. So instead of changing that to a decimal, I can just change it to a positive 1/4 x. Then I have -4 divided by -4. Well, again, negative divided by a negative is a positive, so that's a positive 1. So I would write +1. So from here, I know that my slope is 1/4. So it's already in the form rise over run. Now, it could be written as both of these as their opposite. So the opposite of 1 is -1, and the opposite of 4 is -4. Then my y-intercept is this +1. So I'll start with my y-intercept of +1, and I'll go and put a point. If I use my slope of 1/4, then that means that I would go rise up 1 and run right 4. Now, I also could have used this one, which was a rise of down 1 and a run of left 4. So either of those could have been used. So now that I have my points, I will connect them with a line. And then let's look at our second equation. So that one is 5x minus 4y equals 12. Again, we need to get rid of our x first. So we are going to subtract 5x from both sides. Well, these will cancel, and I'm left with not 4y, but -4y. And I have 12 minus 5x, but that's the same as -5x, and because the 12 is positive, plus 12. Now to get y by itself, I just need to divide by -4 on both sides. These will cancel, and I'm left with y equals, well, again, a negative divided by a negative is a positive. And instead of making this a decimal, I'm just going to leave it as 5/4 x. And then, because this is a positive 12 divided by -4, I'm going to get -3. 12 divided by -4 is -3. So I write -3. Now that I have my equation, I can find my slope. Well, my slope is this coefficient of x, so it's 5/4. And since it's already in rise over run form, I can just show the other value of it, which would be both of these as their opposite. So that could also be -5 over -4. Our y-intercept is this -3, which means that it is -3. So to graph, we start with our y-intercept, and we'll go down to -3. Our slope is 5 over 4, so that means that it's a rise of up 5 and then right 4. Well, you'll see that we end up right here, which intersects with our first line, so we don't necessarily need another point. And we know that this is our solution. Well, that has an x value of 4, and then it has a y value of 2. So the solution is the ordered pair where x is 4 and y is 2.